In this lesson, we'll be speaking about producers in the short and long run. We analyze some important concepts that will be useful to understand later how firms make decisions about how much produce and what value to put or assign in the good and service they produce. The first concept we are going to study is the concept of production. The production function is a functional relation showing the maximum output that can be produced by any given combination of inputs. And of course, in these inputs, we are going to have the factor of productions. So we are going to consider that the production function describes the technological relationship between the inputs that a firm uses and the output that it produces. So we can consider, for example, that the quantity produced is a function of the labor, land, and capital. One of these factors could be sometimes fixed and the other variable. So we can say, for example, that the quantity produced is a function of the labor and capital. And we can use this, or we can say that it's just function of the labor because we consider capital fixed, or that is a function of the land because we consider capital and labor fixed. Anyway, we can type the quantity produced as a function of some of the inputs. This quantity produced will be in a period of time. For that reason, we say that the production is a flow. So it's a number of units per period of time. It could be in a year, in a week, or in a month. When I say short run, I consider the change in just one factor of production. So we have time to consider the change in just one factor of productions. Usually it's just change in labor. So we left the other factor of production fixed, capital, land fixed, and we have just time to change the labor. So we consider then that the quantity produced is equal to a function of L, that is the labor. There are some concepts that help me to understand the production in the short run. One of the concepts is the total product, TP, is the total amount produced during a given period of time. If I call Q this amount, so I'm going to say that TP, or the total product, is just this Q. Another important concept is the concept of average product. And the average product is the total product divided by the number of units of the variable factor used to produce it. For example, if the variable factor is labor, so it will be the total product per unit of labor. So to compute the average product will be the total product divided by L. If the quantity produced is just a function of the capital, then the average product will be the total product divided by the capital. Another important concept is the concept of marginal product. Marginal product is the change in total output that results from using one more unit of a variable factor. Again, if we are speaking about the factor that is variable is labor, so the marginal product will be the change in the total production due to one unit increase or decrease in the labor, in case that labor is the only factor that is variable. So I'm going to type here that marginal product will be the change in the total product divided by the change in L. Of course, as any other function, the total product, the average product, and the marginal product, they're going to have a schedule and also a graph. For example, assume that we have a firm that have this total product schedule. So this total product schedule is defining a function between the variable labor and the total quantity produced. This schedule is telling me that when I have 0 workers, the total production is 0. This is, of course, obvious. And they are telling me also that when I'm using one worker, the total production is 4. If I'm using 2 workers, the total production increase. And this is expected that if we have more workers, then the production is increasing. But that's gonna happen until some moment. If you see here in this schedule, when I have 3 workers, the total amount produced is 36. So it's the double. So actually a new worker is giving me a lot of new production. So these workers is increasing the production. Maybe they are collaborating each other, they are helping each other, and this association, these corporations give an increase in the productions. But if you notice, there is a moment when the production is not increasing so much, and that always happens. Now these workers are too close each other. Now the collaboration is not so good. Now, because the other factors of production are fixed, this doesn't allow that a new worker actually give you too much more production. These things always is going to happen when we have times to change only one factor of production. There will be moments like here when an increase of one worker don't give me so much increase in the production. And that's always going to happen because this is a schedule of a function. We're going to get also a curve of the function. So we can make a curve when we consider quantity of labor as independent variable and the other, the total product, as the variable that depends on this quantity of labor. For each of these points here in the schedule, we have one point in the Cartesian diagram. We represent each value in the total product schedule as a point in the Cartesian diagram. And if we join all these points, we have a curve that is always increasing. So it's going to be a curve that starts in 0, 0 and start increasing until some moment when the increasing is not so much. We can label this as the total product function. Okay, from this total product function, we can compute the average product and the marginal product. Let's compute the average product. So we know that the average product is the total product divided by the labor. So we can make another schedule here just beside this that show me the average product. And the only thing that I need to do is divide the total product divided by labor. Here will be 0 divided by 0. This is impossible, so we cannot divide by 0. But 4 divided by 1 will be 4. When we have one worker, we are producing 4 units per worker. But after that, when I divide 18 over 2 is 9. So this means that when I have 2 workers, these workers work in such a way that they are producing 9 units per worker. 36 over 3 is 12. So in this case, the average product is 12 units per worker. Anytime that we found the average product will be in units per worker. This will be 56 over 4. This is 14. 76 divided by 5, that gives me 15.2. 95 divided by 6, this is 15.8. 112 divided by 7, this is 16. 120 divided by 8 is 15. Now we notice that there was a point when we get a maximum average product. And from now on, we are going to start decreasing this average product. So it will be 124 divided by 9 is 13.8. 127 divided by 10 is 12.7. 129 divided by 11 is 11.7, and finally 130 divided by 12, 10.8. That gives me the schedule for the average product. The curve of the average product can be done here. So we can just plug the point in the Cartesian diagram and then join the point. The marginal product is the change in the total production due to 1 unit change in the labor in this case, because the labor in this case is the variable. The marginal product will be the change from 0 to 1 produce a change in the production from 0 to 4. So it will be the change in the production here is 4, the change in the labor is 1, we divide 4 divided by 1, so the answer is 4. So in this case, because we are going to divide always by 1, the answer will be just the change in the total product. In any other case, we need to divide change in the total product divided by the change in labor. In this case, we are going to divide only by 1 all the time. When you make a schedule of the marginal product, will be a good idea to do this in such a way that each cell here is in the middle of two cells. When it's changed from 1 to 2, the change here was 14. From 2 to 3, the change was 18 to 36 was 18. So, and again, it will be 18 divided by 1. 36 until 56 is 20. 76 to 76 is again 20. From 76 to 95 is 19. From 95 to 112, the change was 16. And you notice now that the marginal product is decreasing. From 112 to 120, the change was only 8. From 120 to 124, the change is 4. From 124 to 127 is 3. From 127 to 129 is 2. And finally, the last marginal product is 1. If you are going to make a curve of this 4 is corresponding to the middle point between 0 and 1. So this 4 is actually corresponding to 0.5. So the 0.5 here in the quantity of labor corresponds to 4 in the units per worker, that is the y-axis. If you are making this, all the points are just plot in the graph at that moment, and now you just the point to get the curve of the marginal product. So we have here that this is the average product, this is the marginal product, and we notice several things here. The first of them is that there is an interception. If hiring 1 unit more, the productions increase more than the average product, then the average product will be increasing. And the opposite, if when hiring 1 unit more, the production is smaller than the average product, then the average product will be decreasing. So there will be an interval here when the marginal product is smaller than the average product. And in this case, the average product is going down. So all of this means that this point of interception will be exactly in the moment when the average product is maximum. So marginal product and average product intercept always at the maximum average product. And this graph also illustrates something more. There will be a maximum for the marginal product. So there will be always a level of output after which the marginal product goes down. This illustrates the law of marginal return. The law of marginal return states that after some level of capacity is reached, the marginal return will decrease. Another concept that will be important to analyze to study the behavior of the producers is the concept of profit. To understand what is the profit, we need to know what is the total revenue. The total revenue is just the total amount of money that the company obtains from selling its goods and services. The total revenue and the total cost, that is the sum of all the costs incurred by the firm in producing its outputs, they are going to define together the profit. So a profit will be just the difference between the total revenue minus the total costs. But we need to be careful. So we need to differentiate between economic and accounting profit. Assume that, for example, we have a firm that produces or sells pizza. Let's call it Michelangelo's Pizza. To compute the Michelangelo's profit, what an accountant will do is to analyze the total revenues of Michelangelo's to see what are the total revenues of Michelangelo's and what are all these explicit costs. Costs like wages that they pay to the workers, the inputs, the value of the inputs, the rent that Michelangelo's paid, the interest on loan, and the depreciation of their machine, for example. So all of these give you some costs, and maybe others. So assuming that these are the explicit costs, they add together all the costs and subtract the total revenue minus the total explicit costs, and that gives you the accounting profit. In economics, we are going to do something similar, where we are considering other costs. If I want to compute the economic profit of Michelangelo's, so what I need to do is just have one schedule as the accounting schedule, but now we're going to consider other costs that were called implicit costs. That are the opportunity costs that the owner have if he was doing other things with his or her time or with his or her capital. So, for example, the implicit cost could be like this: the opportunity cost of the owner's time. If the owner in this time can make $420 working for a company, the owner is losing 420. So this 420 is considered an opportunity cost, an implicit cost that the owner has, but is not considered in the accounting process. Another thing that should be considered in economic is the opportunity cost of the capital. Assume that the owner has 10,000 of his or her capital in this business, and he or she can obtain 4% interest in an investment. So we should consider that this $400 that he or she can make by investing his or her capital will be a cost. So in economics, we have into account this $400 as opportunity cost of as an implicit cost. So if we add together all the opportunity costs or implicit costs, we have 820. So to compute the economic profit will be actually the 3,000 of revenue minus this total explicit costs minus this 820 in implicit costs. So the answer will be $300 just as economic profit. The economic profit is always less than accounting profit because the implicit costs. Don't forget that. So let's study now the concept of cost, and let's focus in the case of the cost in the short run. Some of these costs are fixed and some others are variable. The variable costs depend on the quantity produced. So it means that if the quantity produced changes, the variable cost change. The fixed cost remains the same even if there is a change in the quantity produced. So the total cost will be the total fixed cost plus total variable cost. Here in the total fixed cost, maybe the rent, you should be paying the same rent even if you are producing more or less. And the total variable cost could be the labor. Maybe you need to hire more labor if you want to produce more. So I will be using TC for the total cost. So we are going to use the symbol TC equal TFC, that is total fixed cost, and TVC that symbolize the total variable cost. So TC equal TFC plus TVC. There will be other concepts. For example, the concept of average cost. If Q is the total quantity produced, so TP, then the average total cost will be TC divided by Q. So the total cost divided by the quantity produced. So again, we see here that this is the function of the quantity produced. And remember, this TC depends on the quantity produced. So here we have a function that is a quotient between a function that already contained the quantity produced divided by the quantity produced. So we can say that the average total cost is the total cost per 1 unit produced. We have also the concept of average fixed cost. The average fixed cost will be the total fixed cost divided by the quantity produced. This is again a function of the quantity produced. The numerator here in this fraction is a constant because the total fixed cost will be always the same number, but the average fixed cost will be changing because it depends on the quantity. If the quantity is bigger, the total fixed cost goes down. And finally, we have the average variable cost will be the total variable cost divided by the quantity produced. Again, here the average cost is a function of the quantity, and this is function actually is a quotient of a function already of a quantity. So this TVC depends on the quantity and is divided by the quantity. That means that we have another relation between the average total cost, the average fixed cost, and the average variable cost. If we get the previous equation and divided each of these terms by quantity, so we're going to have TC over the quantity, that is this, the total average total cost. We have here TFC over a quantity, that is the average fixed cost, and we have here TVC over a quantity, that it will be the average variable cost. So we have a new equation that will be ATC equal AFC plus AVC. The average total cost will be equal to the average fixed cost plus the average variable cost. It will be another concept that is the concept of marginal cost now. And the marginal cost will be the change in the total cost due to the unit change of the quantity. So is the increase in the total cost resulting from increase in output by 1 unit. So the marginal cost will be just the change in the total cost divided by the change in the quantity. Since the total cost is a variable of the quantity, so this marginal cost will be a function that depends again on the quantity. To illustrate how these cost functions works in a firm, let's see an example. The following table gives the total cost structure of one firm in a perfect competitive market. Complete the table by computing total variable cost, average total cost, average variable cost, and marginal cost at each level of output. What are the fixed costs of this firm? So we have the schedule, and in this schedule we have the quantity produced and the total cost. So we have actually the total cost function that, as I told you, it depends on the quantity. I will say here that when the quantity produced is 0, we have a total cost of 24. But if the quantity produced is 2, the total cost is 48. When the quantity produced is 4 units, the total cost is 64, etc. But something important, the total cost when the quantity produced is 0 is 24. So it means that we have a cost even if the quantity produced is 0. So if that is the case, and as I told you, the variable cost depends on the quantity produced. And if we don't produce anything, the variable cost is 0. So it means that this 24 needs to be the fixed cost. And because the fixed cost is always the same, it's a constant, so we have a value for the fixed cost. The fixed cost is 24. So the total variable cost here is 0, and the total cost that is up here, we know that the total cost is the fixed cost plus the variable cost. So this 24 needs to be the fixed cost. In the second row, the total cost is 48, and the fixed cost we know that is 24. 48 minus 24, that gives me 24. So the 24 need to be the variable cost when we are producing 2 units of output. This 24 plus the 24 that is the fixed cost give me the 48 that we have here at the total cost. The variable cost in this case need to be 40, because if we have 40 plus the 24 as of the fixed cost, give me the 64 that is the total cost. In the fourth row, so when the quantity of output is 6, so it needs to be 84 minus 24, so it will be 60, the variable cost. The variable cost in the next one need to be 84, that is 108 minus the 24, that is the fixed cost. Here, the variable cost need to be 140 minus 24, that is 116. And finally, the variable cost in the last row will be 192 minus 24 is 168. So we compute the total variable cost. And we can compute the average total cost and the average variable cost and the marginal cost. So to compute the average total cost, the only that we need to do is divide the total cost divided by the quantity produced. So for example, here will be 24 over 0, but we cannot divide by 0. So this is not a number that this is not defined in here in the first row. But in the second row will be 48 divided by 2, that is 24. And in the next row will be total cost, that is 64 divided by the quantity, that is 4, is 16. So let's type 16 here. So we can fill the whole schedule now. As 84 divided by 6, it will be 14. 108 divided by 8, the answer is 13.5. 140 divided by 10, the answer is 14. And 192 divided by 12, the answer is 16. So we have computed the average total cost. You should notice that the average total cost go down and then after that go up. We say that the graph of the average total cost is U-shaped. The same is going to happen with the average variable cost. So we are going to divide the total variable cost divided by the quantity. For example, in the first row will be 0 divided by 0, that you cannot do that, so this is not defined. But in the next one will be total variable cost 24 divided by 2, that will be 12. The next one will be total variable cost 40 divided by 4, it will be 10. And the next one will be total variable cost is 60 divided by the quantity, that is 6, is again 10. Then the next one will be 84 divided by 8, and the answer is 10.5. The next one will be 116 divided by 10, the answer is 11.6. And finally, 168 divided by 12, and the answer is 14. Again here, the graph for the average variable cost will be U-shaped. It's going down 12 to 10, and then start going up 10, 10.5, 11.6, and 14. And finally, the marginal cost will be the change in the total cost per unit of production, per unit of output. So it will be the change here that was from here to here was 24 in 2 units, because the change in the quantity produced here from here is 2. So it will be 24 divided by 2, and the answer is 12. So 12 will be the marginal cost here. The marginal cost here will be 48 until 64. There is a change in 16 divided by 2. 16 divided by 2 is A, will be the marginal cost. The change in the total cost in the next one will be 20 divided by 2 is 10. The next one will be from 84 to 108. The change was 24. 24 divided by the change in the quantity, and I notice that the change in the quantity again is 2. So it will be 24 divided by 2 is 12 again. And then again, the change here from 8 to 10 units will be 108 to 140. The change is 32 divided by 2 is 16. And from here to here, the change was 52 divided by 2 is 26. And you should notice that the rows of the marginal cost are in between the rows of your previous schedule, and that is because each of these marginal costs refers to a change from one to the other. This 12 doesn't correspond to the first row, doesn't correspond to the second row. It actually corresponds to a change from the 0 to 2. So if I want to make a correspondence between this number and a number in the quantity, it will be the number here in the middle, that is between 0 and 2 is 1. So this 12 is the image for 1. This A, for example, is the image for 3, etc. in the function. That's the marginal cost, seeing marginal cost as a function of the quantity. So this 12 is the value corresponding to the number between 6 and 8, so corresponding to 7. So now we can do a graph for each of these. For example, for the total cost. So that we need to do is just make in a Cartesian diagram a point for each point of the total cost schedule. And remember, the independent variable here will be the quantity, and the dependent variable will be the cost. When the quantity is 0, the total cost is 24. For example, here will be a point, and then we can make a point for each of these. So we make the graph will be points like this, and then we join the point to make the graph of the total cost. So this will be a graph of the total cost will be something like this. It's a graph that is always increasing, and each time the increase is bigger. Okay, we have that this is the total cost, and we can also make the graph here for the total variable cost. And all this graph, the total cost and the total variable cost, depends on the quantity. The unit for the x-axis will be unit of quantity, and the units for the y-axis will be dollars. For the total variable cost, 0 corresponds to 0, and 2 correspond to 24, etc. etc. All these points. Just join the point after that, and this gives you the graph of the total variable cost. The total cost and the total variable cost, always gonna have the same separation between the graph. So this will be parallel graph, and the difference is just the total fixed cost. So the total fixed cost is 24. So the total fixed cost will be a constant, will be a horizontal line that crosses the y-axis in 24. So will be something like that, the total fixed cost. In this Cartesian plan, we have unit of quantity at the x-axis and dollars in the y-axis as a unit. We can graph the total cost, the total variable cost, and the total fixed cost. The average total cost, the average variable cost, and the marginal cost, they will be made in a Cartesian diagram that have quantity in the x-axis, but has cost of the unit, so dollars per unit in the y-axis. Okay, remember, the average cost is just the cost per unit. The marginal cost will be the cost per unit increase. So all of this, the y-axis. So these three graphs can be made in just one diagram. So let's do the average total cost. We need just a point for each of the value of the average total cost. So 1 point corresponding to 2 and 24, 4 and 18, etc. So 2 and 24, 2 and 24, and then 4 and 16, etc. So all the points that we have. And then just join the point. The average variable cost will be something similar. So just make the correspondence between 2 and 12. So 2 and 12, and continue giving the points that you need. The last point will be 12, 14, and then join the point. The average total cost and the average variable cost, they are always closer and closer. And the reason that happens is the average variable cost plus the average fixed cost will give you the average total cost. But the average fixed cost is always smaller because this total fixed cost is constant, and the bigger the quantity, the average fixed cost is going to be smaller. So this difference will be always smaller. And finally, we can make the graph of the marginal cost. So this 12 corresponds to number 1, so that is the number between 0 and 2. So 1, 12, so will be a point here, and will be another point in 3, 8, so will be here 3, 8, and another point in 5, 10, 5, 10, and then 7, 12, 9, 16, and finally 11, the number between 10 and 12, 11 and 26, and then just join the point. If the marginal cost is smaller than the average total cost, then the average total cost will be decreasing. Type here that this is the marginal cost. The marginal cost is smaller than the average variable cost. The average variable cost will be decreasing. But if the marginal cost is bigger than the average variable cost, then the average variable cost will be increasing. Obviously, if the next quantity produced give you a cost bigger than the average variable cost, then the average variable cost will be increasing. And the same happens with the average total cost. If the marginal cost is bigger than the average total cost, then the average total cost will be increasing. So that means that the marginal cost intersect the average variable cost and the average total cost in the minimum of this function. Let's type this to remember. So the average total cost, remember that it's the average fixed cost plus the average variable cost, but also remember that the marginal cost intersect the average total cost and the average variable cost at the minimum of this curve. Let's analyze now the cost in the long run. The time frame enough or sufficient to change any factor of production. In the short run, at least one factor is fixed. In the long run, all inputs are variable. So land is variable, capital is variable, and labor is variable. In the long run, there are numerous ways to produce any given output, and I will be explaining this later. In making profit maximizing choices, the firm tries to be technically efficient. And technically efficient means that we're gonna try to maximize our output and minimize our cost. Technical efficiency occurs when a given number of inputs are combined in such a way as to maximize this level of output and obviously minimize the level of cost. But let's see how the producers can make this choice. How the producer can choose in which factors they are going to put their money. The way that producers make choices is similar to the way that consumers make choices. While consumers try to maximize utility, producers will try to minimize their costs and maximize their products. So the marginal product plays a similar role that the role that plays the marginal utility for the consumer. So if we are thinking just in two factors of production that they need to buy, let's see labor and capital. Then using K to represent capital and L to represent labor, and PL to represent the price of the labor, PK to represent the price of the capital, and MP represent the marginal product, the necessary condition for cost minimization is similar to the condition for the consumers. So the marginal product in one of the factor divided by the price of this factor will be equal to the marginal product of the other factor divided by the price of that factor. Or equivalently, rearranging this equation, it will be P MPK divided by MPL equal to price of the K divided by the price of L. So that gives me the condition or the equation that we need to solve in case we want to know how the producers made the decision. So let's see now one example in which a company is in a long run time frame. The cost that the company experiences in the long run is studied in a curve that is called the long run average cost curve. To understand how this curve appears, it would be a good idea to show an example. Assume that we have the table that shows the production function of Charlie's balloon rise, and that Charlie pays $500 a day to rent a balloon and $25 a day to hire a balloon operator. A table like this shows me the production in the long run. We are assuming that there are two factors of productions, the labor and the capital. Let's see here the number of balloons Charlie is using. the number of balloons is a variable, and the labor, the number of workers per day Charlie is using, is another variable. So when I say here, for example, that we have number 4, it means that when Charlie is working with 10 workers and 1 balloon, they are producing 4 rides. Or here, number 15 means that when Charlie is using 20 workers and 2 balloons, then the number of rides is 15, etc. So this table show me the production taking into account that the two factors of productions are variable. But for making this analysis easier, it will be a good idea to divide this in possible short-run tables. Tables that show me what happened when I let fix the number of balloons. For example, if the number of balloons is 1 and I don't change this number, I will be working in a short run time frame. So to analyze the long run cost, what I'm going to do is to analyze the possible short runs leaving fixed the number of balloons. So let's analyze this. Let's see what happened in plant 1. So when we are using only 1 balloon, what will be the cost? Or what could happen in plant 2? What happens if we are working with 2 balloons and the only variable is the number of workers? Or what happened in plant 3 when we let fix the number of balloons in 3 and we just change the number of workers? Or what happened in plant 4 and we are just changing the number of workers? Notice we have here is the quantity produced, because in plant 1, when we have 10 workers, we produce 4 rice. When we have 20 workers, we produce 10 rice, etc. Because what I want to do is a cost schedule, what I'm going to do using as an independent variable the quantity produced. So when I see this 4, it means that Charlie is working with 10 workers. Oh, here in plant 2, when I see this 19 in plant 2, it means that Charlie is working with 30 workers. Analyzing these 4 tables will be equivalent to analyze the long run situation for Charlie. So let's see what happened in plant 1. In plant 1, Charlie is using 1 balloon. When Charlie uses 1 balloon, he pays $500. And to produce these 4 rice, he needs to hire 10 workers. Charlie is paying here 500 plus 215 workers. So Charlie is paying 750. So we have the total cost in case that Charlie is producing 4 rice. If Charlie is producing 10 rice, Charlie is using 20 workers in plant 1. So 20 workers actually means 10 workers more, so 250 more. So it will be 1,000. And etc. If Charlie is producing 13 rice, he is using 30 workers, and that means that he's paying $250 more. In any case, will be always 10 workers more. So here will be 1,500 and here will be 750. So now it will be easy to compute the average total cost. And the average total cost in this case will be 750 divided by 4, or 187.50. Remember, the average total cost is the total cost divided by the quantity. Will be 1,000 divided by 10, that is 100. And here will be 1,250 divided by 30, that is 96.15. 1,500 divided by 15, that is 100. And 750 divided by 16 is 109.37. And now I have the average total cost schedule for Charlie in a short run when it's fixed the number of balloons. And the number of balloons, I leave it fixed as 1. So I can make a graph of this, for example. Okay, let's see what happened in plant 2. In plant 2, we are using the same number of workers, and the only thing that we are doing is just getting 1 balloon more. Charlie will be spending 500 more. So in this case, to make 10 rice, Charlie needs 10 workers, so he needs 250 plus 1,000 in balloon will be 1,250. Actually, it was 500 more than in the previous situation. And to produce 15 rice, Charlie needs 20 workers. so it will be 250 more, and etc. We need to add 250 each time, so it will be 1500, 750, 2000, and 2250. And then I can compute the average total cost. The average total cost will be just dividing the total cost divided by the quantity produced. 1250 divided by 10, it will be 125. 1500 divided by 15, it will be 100. And 1750 divided by 19 is 92.11. 2000 divided by 20, again 122.50 divided by 21. The answer is 107.14. And you notice that anytime that I compute the average total cost, the average total cost go down and then start increasing. So they have, remember, a U-shape, the average total cost in the short run. And so far, we continue working in the short run. Yeah? For each of these cases, for example, in plan 3, the thing that Charlie needs to do is just rent one balloon more. So he's going to spend 500 more in each of the situation. For example, here that he's using 10 workers, it will be 1500 in balloons and 250 in workers. Here 250 more will be 2000, 2250, 2500, and 2750. Now we can just divide it by the quantity to get the average total cost. 7050 divided by 13, 134.62. 2000 divided by 18, 2250 divided by 22, 2500 divided by 24, and finally 2750 divided by 25, 110. And we have the schedule in the short run for Charlie when he is working with 3 balloons. And in the short run, we have that when he is using 4 balloons, 2000 in balloons, then the total cost will be 2250, 2500, 2750, 3000, and 3250. So now we compute the average total cost, and the average total cost will be 150. In this first case, 2500 divided by 20, 125. 2750 divided by 24, 114.58. 3000 divided by 26, 115.38. And 3250 divided by 27, 120.37. That gives you the total schedule when he's using plan 4. So we have 4 short run cost tables, and we of course can make now the graph of each of them. If I made a graph of each of them for the plan 1, for example, when the quantity produced is 4, the average total cost is 187.50, and etc. So I can give all the points that I need for making this graph. Okay, so we have a graph that will be just join the point that we have so far, and then we join the point, and we have a curve for the short run curves when we have plan 1. Let's call it ATC1. So this will be the average total cost when Charlie is using 1 balloon. What happens if we do the same with plan 2? When the number of rides is 10, the average total cost is 125. So I'm going to type here 125 will be like here. So will be this point, and then just find a point in each of the cases. For example, for 15 will be 100, 15, 100, and 15 will be here, etc. Give all the values, and when you get all the values, just join the point to get the average total cost. And this is the average total cost when Charlie is using 2 balloons. And then we're going to do the same when Charlie is using 3 balloons and when Charlie is using 4 balloons. For the third plan, we have 134.62. So, and this means that is when the number of rides is 13. So 13 is here, 134.62. 134.62 will be like here. and then continue given point when it's 18, and etc. So you just, and then at the end, the point to have the average total cost in the third situation. And we continue in the same way for making the other average total cost, and we have the average total cost when Charlie is using 4 balloons. This will be the average total cost. And in this way, we analyze the whole situations in the long run. Now, we see that there are several ways of producing the same amount of rice. For example, to produce 10 rice, we can work with plan 2, 10 workers, and 2 balloons. Or we can work with plan 1, 20 workers, and just 1 balloon. So there are several ways to get the same output. Here, for example, 24 can be achieved using 30 workers and 4 balloons, or 40 workers and 3 balloons. So that explains why in the long run we can produce the same amount of output in different ways. But there is another situation here. What happens if Charlie is gonna produce 10 rice? In which plan is Charlie going to work? Definitely he's going to work in the plan number 1 using 1 balloon, because the average total cost will be smaller. So this helps us to analyze how will be Charlie working actually. If Charlie is producing 18 rice, for sure Charlie will be working with 2 balloons. As you can see, there are several ways to produce 18 rice. Here we plant 2, we plant 3, and we plant 4, and we plant 1. However, this is the lowest cost, so Charlie is going to be working with plant 2. Or if Charlie is producing 22 rice, Charlie will be working in plan 3. So that helped me to see that the real important points in this graph are the points that are below. So actually there is a curve here, and this is the curve that we call long run average cost curve. This curve helped me to see what is the way that Charlie is working. Charlie is working in such a way that he has the lowest cost. This curve is separating the possible costs that Charlie could have from the cost that Charlie cannot have. So the unattainable costs are here. So Charlie obviously would like to have a smallest cost, but no, these costs are impossible. The possible costs are at the top, and this curve, the long run average cost curve, is separating the attainable cost with the unattainable cost that Charlie is dreaming, but he cannot achieve. So this is the curve that helped me to understand how are the costs for Charlie in the long run when we are analyzing all factors of production. Let's analyze a little more how is this curve. Let's try to obtain information of the form of the long run average cost curve and define the concept of economies of scale. So the long run average cost curve will be a curve like this that will have several intervals. The first interval is a decreasing interval. When the quantity is increasing, the cost is decreasing. The scale of operation is in such a way that anytime that we are increasing our quantity, the cost will be decreasing. For example, moving from here to here makes that the company experiment a decrease in the cost until one point in which the long run average cost get a minimum. So the company will be working more efficient if the level of output increase. So in this interval, there will be a decreasing of cost and of course an increasing of return. This point in which the firm is working most efficiently it will be called the minimum efficient scale, and at that point the average cost is minimum. Over this range of output from 0 to QM, from 0 to the minimum efficient scale, the long run average cost is falling, and the firm is said to have economies of scale. So we can say that the minimum efficient scale is the smallest output at which the long run average cost reaches minimum. So there will be an interval of quantities in which the average cost is constant. The minimum quantity in this interval is the minimum efficient scale. So the minimum efficient scale is the smallest output at which the long run average cost reaches minimum. So it will be several points of minimums. But the minimum efficient scale is the smallest output at which the long run average cost reaches minimum. So it will be an interval in which there is a constant average cost, and of course will be a constant return. And it will be another interval in which there is an increasing of the average cost. And this increasing of average cost produces a decrease of return. We will say that the firm is experiencing these economies of scale. And with that, I finish my explanation. Thank you.